This is interesting. This 511 is the first scope Tech made. This was Howard's dream when he started. So Howard Ballum and Jack Murdoch were the main founders. There was four of it. Howard had the idea, and Jack had an appliance store in Portland on Hawthorne. And they knew each other before the war. The war came in World War II, and Dean went into the Coast Guard, and Howard went into Signal Corps. And he had different assignments. He ended up in Europe working on radar. But he'd always had this idea. He was familiar with oscilloscopes. And so when they got back together. They kept running the appliance store for cash, and then the upstairs was where they started Tektronix. So it started in 1946. This ad here is actually by 1948. They actually had the first product, which is this 511 oscilloscope. Before they came out with this oscilloscope, they came out with this calibrator. We think that Jason serial number. This was like the first product Tech ever built. They built 10 of them. We don't believe they ever sold any because nobody really wanted a calibrator for an oscilloscope in those days. But they needed it for calibrating. At the time, well, this one you can see the price is $7.95. But much like anything with electronics, compared to the competition, this was smaller. It worked better, and it was lower cost, even though it's fair size. Well, oftentimes the power supplies were like more on this scope over here. The bottom is the power supply.
Wow.
And so they're really big packages.
So power supplies built in this one?
Yes. We can actually see one of them. It's this here. It's the all apart. Yeah. At that time, when they first started, everything was point-to-point soldering. The CRT. Since you worked, you have an idea what that was.
Right. I thought there was a lot more inside than that. That's amazing.
Yeah. So after that, then they came out with some higher frequency models. Still a little bit.
512, 513, and 514. Huh.
Yeah. See, I think it was 5 megahertz to begin with. This one is 20 megahertz. Now the price is $16.50. This is 10 megahertz, $9.50. Still lower sensitivity. Well, down to, I'm sorry, 0.300 of a volt. They also built some curve tracers. This one was made for matching tubes.
Okay.
Things you needed to make the products, and then they decided to sell them outside also. These are still popular, like on eBay. Nobody had ways to match transistors. That's typically with the circuits you wanted matching parts. So you often had 2 inputs on the front port. You could switch back and forth. And now you could lay them out more neatly. It helped with reliability. Other folks were using like phenolic strips, but the ceramic with the silver places where you would solder the components in turned to be more reliable. You can see it, a lot of stuff there, but it really neatened things up. And now if for troubleshooting, you had a place to go look for the part you were looking for, rather than hunting.
Right.
Got into 1950, they were outgrowing the plant, and so that's when they decided to move west. This is what they call the Sunset campus. This is just down near this This is looking west on, this is Highway 26, so the Providence Hospital is
Okay.
back here.
Mhm.
This was the first building, and you can see the parking lot's pretty full. They added the second building to build components, and this is where they ended up building CRTs. There's a whole story about how they were buying CRTs from Dumont and RCA, and they were thinking they were getting seconds. There was a lot of rejects, and because it's such an important part of the oscilloscope, it reflects much on your quality and your capability, what you could do. So if you were building your own, you could really more write your own destiny. One, obviously, not only could they build their own tubes, and then also created where they built the storage tube. They could build faster tubes. Eventually, then you could build square face tubes. And that's kind of a whole story into itself. They took a chance and they studied it for a while, and I think it was 1953. Howard told one of the guys, Monday you're going to start building a CRT plant. What? The recipe wasn't all known at that time, so there was a lot of research and problem solving.
So they blew all their own glass and stuff too?
Yeah.
Wow.
Very long. And basically they could sell everything they could make. And so that's when they started on then they bought the land here to build this campus.
Okay. Yeah, this is where I started, right here.
Okay.
Building 47.
Right, I worked in 47 also.
I remember sticking my boiled eggs in the microwave, not knowing they were going to blow up.
Right. So this was in 1965.
Okay.
Yeah, the
47's there.
You're right. 39, 19, and 13.
What was 13? This
That's
building?
This building.
What was in here?
That was ceramics.
Ceramics.
Oh, this was 13?
Yeah.
So I did a lot of work in 19 when I went into the IT department doing telephone.
Oh, yeah.
I worked on the Dan Ray system.
Yeah.
Yeah.
You might have run across my dad. He worked for General Telephone, but he came over here a lot to
What was your dad's
troubleshoot.
name?
Dick Johnson. I mean, he would have been in and out. He was, worked for General Telephone, but yeah, he talked about spending a lot of time here. And I remember they had the battery room.
Yeah,
The operators. And, yeah. So actually, this building they actually had two big kilns in the back end to make the CRTs. Later, when they figured out how to make ceramic CRTs, they to glue the face plates on and attach the funnel. Anyway. Yeah. So this is a picture from 1983, and that's when there was 24,000 people on the campus.
I was working here in 83.
They were doing a lot of that was nuclear testing time. This is actually a 1 gigahertz oscilloscope.
1 gig in an analog scope?
Yes.
Wow.
Well, in fact, if you look, there's no front-end amplifier because you didn't have components that would work that fast.
What is this coil here? That's
That's a-
RF, isn't it?
It's a delay line.
Delay line.
Yeah.
Okay.
So you can line everything up. The signal would come in direct, and and there was no storage, so that's what they made these cameras, and they would trigger the camera to take the picture when the scope triggered, and small screen, even though it was a bigger CRT, and you could only write a small area so fast, distance. But if you look behind you, to be able to get longer records, this is This looks more like a building. They would actually put these in vans and take them out to the test site. You can see these are cameras. These are all those 1 gig scopes, and they'd figure out how to put them all in sequence. And so they would sequence them through to get their record length, to get a long record length. You know, take the pictures and then put them all back together.
Wow.
And the challenge was when there was stuff down on the ground that was going to detonate, was to get your signal transferred up your cable to your scope before everything disintegrated behind it. This particular scope was in the Hidden Figures movie. Guy in Portland, Paul Pierce, he has a collection of IBM computers, and so the movie company contacted him for their mainframe computer, and you can see on site one of the, to be authentic, here's that's this computer here.
Yeah, I watched that movie not too long ago.
Okay. So if you were watching close, you see there was a
Yeah.
tech scope on it. So after they took the set down and stuff, Paul asked the museum, he's a friend of the museum, he asked if we wanted the oscilloscope.
Oh,
So
wow.
we actually have it, and like most stuff, it still works.
And this is the scope that's right here?
Yes.
Oh, that's cool.
Yeah.
That's really cool.
Right. Usually we do a rotating display here. This happens to be one we do for STEM events. This is some LEDs, and it's a tricolor, so it activates the different colors, activate with different voltages. And they were showing pulse width modulation here. Gets dimmer and brighter. So we show kids that primarily. That's why we put it together. But that was back in the 70s test equipment. That stem there. This was another STEM demonstration we had at Dundee. One of the things, the microphone, and you can see your voice on the scope. Kids love that. You can see music. In particular, if you
Can see your frequencies.
yeah, and if you half that, you can see it doubles. You don't need to necessarily do that. And have you heard of a theremin?
Oh, right.
And this, I think, is anyway. You can watch our YouTube video that does a much better job than me.
That's cool.
It's Rogers, Oregon. That came about. Two of the engineers working for Tech had this idea that they wanted to start an organ company. So they went to the board and said, "Hey, can you help us with some funding?" And the board said, "Well, we really don't want to branch out into music. We're test and measurement." So Howard liked the idea, and Howard actually invested in it. He actually there's a picture here somewhere of Howard. Well, this is Howard's Wurlitz or pipe organ he had in his house. The company ended up in Hillsboro, and they were there for many, many years. The company still exists.
Building
but
organs?
Building pipe organs.
Wow.
And that's why we have pipes.
Like 41.
Yeah.
I like the way they number it. It just keeps going up.
Yeah. Keep getting better. About the same time that they were deciding to build their own CRTs, Howard also had the idea that rather than building just a single oscilloscope, going to plugins, now you could have one mainframe and you didn't have to buy a whole new instrument if you wanted just some different capability. or a spectrum analyzer or
Right,
something. And so these are some of the plugins. Oh, this is a time base generator.
Got a spectrum analyzer right there. Wow.
Yeah. Still built with the ceramic strips and meant to plug in and characterize the mainframe.
Wow, that's cool.
Yeah. So I mean, again, it was more value for the customer.
Right.
Well, and as the story goes, for customer service, if you a customer was down and they needed a part, didn't have it, Howard would shut the factory down until you made that part for the customer, and then you would start manufacturing back up again. You ever hear of that happening these days? Ever happened when you were and this is just X and Y mode. Yeah, these little microcontrollers make doing things like that easy to do. Yeah.
Never would have thought that was an oscilloscope function. The game?
Right.
Yeah.
Well, it's XY mode, so you don't have the time base. You're just plotting X and Y against each other, and it allows you to draw things. This was kind of famous. The CRT in here was really fine trace, and it has a really high writing rate, and so these oscilloscopes with the CRT were pretty popular. Actually, there was a guy that he worked for Linear Technology. It was a linear analog IC company. Even up into 2000s, his app notes he'd write would still use these the 547 scope. That was his favorite scope. He'd have a picture of a round screen, but most of the analog functions aren't super high bandwidth.
Right.
So the older scopes would still work. Well, he loved to collect Tektronix equipment. Well, they were building big scopes. They also built portables. So this one is actually was in 1960. This was actually it's this one here that this sign goes with. You can see how this is kind of an interesting story. This is an A. The 310 was built in 1955 using a printed circuit board. It was new at that time. But you'd think, well, that's an easier way to build. Well, the process was additive. It wasn't like etch subtractive. And so for the through holes, they'd use rivets. And those turned out to not be very reliable. So when they redesigned this, like 4 years later, they actually went back to using ceramic strips because it was more reliable. Tech also got into calculators.
Wow.
I can remember having the 31 at Hillsborough High School. That would have been in like 1975. Probably this one actually works. Uses Nixie tubes for the display. Actually, I took this to Dundee. The kids got a kick out of well, showing him tubes. And this one, we broke this at Dundee. And then I think Pat, he did a little more breaking it down, but it allows you actually to see the inside and see the numerical stack
Okay.
of how they made the Nixie tubes.
That's pretty cool.
These products came out of Redmond. The TDRs and OTDRs, so time domain psychometers, optical. And then Tech got into and out of spectrum analyzers multiple times. They ended up OEMing some for a while. And then HP laid off their group, Tech bought them, and then they weren't making money and they laid them off again. It's not one of our better stories. But anyway, this, well, well, I think it was 1974. Howard Ballin went to Japan and created a deal with
Joint
Sony.
venture.
Joint venture. Yeah.
With
This is
Sony.
with Sony.
Uh-huh.
They called it Sony Tech. And later, Tech bought it out, and it was all Tech. And then they too decided they brought the products, the signal sources that were left to Beaverton, and they ended up just getting out of Japan. But this is a spectrum analyzer module that went with the scope. Most of the stuff, like the scopes and stuff that were smaller and more portable. This is just a leaded antenna. This is showing you the radio stations in the area.
AM. Or would that be? Doesn't matter.
Yeah. This is the carrier frequency.
Mm-hmm.
And this is a rapid scan spectrometer. So you can, as the colors in the light bulb change, you can see the different peaks show up on the screen. And it shows you both the wavelength and then also the magnitude. Through the, as the story goes, the guys that created this, this was in the 70s. They said, "Oh, we think we ought to have a rapid scan spectrometer," and they just went off and built it.
Wow.
There wasn't a lot
Wow.
of justification, stuff to go through to get approval to build it. So after Tech started using when they started using the printed circuit boards, they no longer needed those ceramic strips. But Howard always had this idea that he wanted to be able to build his own, building here in Syracuse, but he wanted to have a square face. So they came up with the idea of using ceramic to build the funnel of the CRT, and then attaching the gun to it, and they use soda lime glass for the faceplate. Now you could, instead of having to do it all out of glass, now you can do it out of ceramic, and you can make it smaller, rectangular. This particular one, the 453, is kind of a unique story in that IBM, when they were building their mainframes, you had to calibrate your memory, and so they'd ship a scope with every computer that they built.
Oh wow.
And as the story goes, the IBM says, "Oh, we'll just go build it ourselves." Tech was, wait. We want in on that. Well, what are your requirements? He said, well, it needs to be 50 megahertz, and it needs to fit under an airplane seat. So they came back and put a program together, came up with this scope, took it back, and walked in, and as the story goes, a couple of engineers at IBM met him, and they said, great. Took the scope, and they started walking off, and the sales guy said, well, don't you want to demo it? If you need somebody to show us how to use it, we don't want it. We'll meet you back here, you can't follow us. So a couple hours later, they came back and they said, we'll take 70,000. Wow. Or something like that, as the story goes. Anyway.
So they loved it.
They loved it, and it worked out well. Excellent. This one actually had a battery pack. You can see the date, 1966. I remember my dad, who worked for the phone company, was issued one of these. And I don't know if this has the battery pack in it. Maybe it's like a whole other module that fit in the back of it.
This is a scope I have at home.
Yeah.
It's a beautiful scope.
Somebody came up with the idea of a scope artist, and so you can draw things by changing these controls. This is I don't remember what all of them do. I probably can't get back to what I had, but anyway, if you want, kids can play with that, and that's one things we have for kids to do. Jumping, well, kind of skipped an aisle in time frame with over here. So these are more Sony products. See again, they're smaller. This is a data analyzer or logic analyzer. Well, not a data analyzer, but much smaller and portable. So jumping
Never seen
ahead,
one of those.
excuse me.
Never seen one of those.
This was one of the first. Well, let's jump over here first. Because they could make their own CRTs, they could make these small scopes. These actually have a CRT in them. And you can see the packaging. You can make them portable for service. And they had a battery in them, so they were truly portable and isolated. So you could make isolated measurements. So they built quite a few different models of those.
This was all the vintageTEK products here?
No, these were actually Beaverton.
Okay, wow.
Yeah. And they built these in North Portland. They had their own group that built these for years. So then, come about 1990, you started getting flat panel displays. This was a product. It's only like a 5 megahertz oscilloscope with a DMM. This actually got OEM by Mac Tools. Tech kind of went in and out of automotive quite a few times also. Pro packages and stuff. This was part of that. And they had a couple other DMMs that they put in that too. Well, so at that time, flat panels were coming into vogue. You might have known Merlin Kaufman. He was one of the primary designers on this product. This is a digital scope. It uses FISO technology. FISO is fast in, slow out. So
CCDs?
that was another example of it. That was used in the 2400 portable scopes. By the time they got to 1990, they figured out how to do it in CMOS ICs. A guy by the name of Steve Sullivan was the main architect and designer of those. So this is, much of the circuitry is like what they called the TDS 300, which was a smaller, more form factor like this. It was not as big, but and it still had a CRT or raster scan for the display. But taking that and shrinking it, they came up with this product. Battery pack, it was a long tubular battery that goes in here. Again, isolated channels and easy to carry around. Well, about that time, they got this guy, the FISO designer, he was in central engineering. He had the idea of making these smaller oscilloscopes. Actually, this is the first one. Monochrome, but the whole focus on this was low cost. He came to me and he said, I'm looking around, I look in our database, the lowest cost front panel I have is $150. He says, that's what I want to spend for the whole scope. Can you help me? So I got involved with it. It was a lot of fun. Steve kind of used me as a sounding board for some of his ideas. Anyway, so I had some input to this. But
$150 for that scope?
The manufacturing cost.
On
We sold it for $995. We wanted to be under 1,000 so you didn't have to get a CCA. So, well, you're familiar with 7,000 series scopes. This was the follow-on then. This is a 11,000. And by the time we got to 11,000, the package is getting bigger. That they actually this was a monitor that they turned on its side. But the user interface changed. Now you're doing things with what was a touchscreen with diode array and these knobs to select things. And they just never really caught on very well in the industry. I would say it went on the failed side. you took up a whole lot of desk space, and they were expensive, and they were not very friendly to use. And so this was started in 1990. This is what they called the Columbia platform. This is actually designed from the ground up to be all digital, with A to D converters. Well, they started off with a model, and then they built them all through the 90s.
Is that a floppy disk drive there?
That is a floppy disk drive.
Wow.
Yeah. And it was one of the early ones because the standard color for floppy disk drives was black.
Mm-hmm.
And originally they said, oh, we can't have that. And then purchasing said, costs us too much to get color. So later ones they're black. Find that with other peripherals. But they redid the whole user interface. This was interesting. They wanted a color display, but their flat panels really weren't available yet, and you couldn't find a small raster scan CRT at the time that was color. The TV market was taking off, and every TV wants to always be bigger. So you can see this is color here. Tech developed this technology on their own. It was actually Howard Ballum had met some guys when he was in Europe with the Signal Corps that had what they called field sequential color. And so he told the guys here, and Tech went over and bought the technology, and it took like 4 years to actually work all the bugs out and make it work. But it uses an analog CRT monochrome that runs at 3 times your update rate. So it runs at 180 hertz. And on the front of it, you have a liquid crystal color shutter. So red, green, blue, you put that on the front, and you flash between that filter on the front at 180 hertz to give you all 3 colors, and then your eye integrates it.
Wow.
To look like a single display.
Mm-hmm.
And that's what they call it, field sequential color.
So those colors are actually showing up at different times.
Yes.
But our eyes don't see that.
Yeah, they don't react fast enough.
Right.
Right.
That's cool.
Yeah, so they're running at 180 hertz, but they're there, so yeah, you don't. I mean, and that's part of the challenge. No flicker, and but because it's based on a CRT, you get wonderful contrast, and you get really sharp. It's like having small pixels.
Mm-hmm.
So I think actually the software, this is 640 by 480 for resolution.
Okay.
So, like we were talking before about the update rates, the display isn't updating that fast. When they first built the digital scope, they were updating at like 60 hertz, and you had this problem that you were missing a lot of this stuff. So then they came up with a version they called InstaView, and that they would then acquire more often and then display it. Well, you still had your probability of catching things were better because you were running your acquisition system much faster, but you shut it down while you displayed your image, and then you go back and acquire. So you still had gaps. So by, I think it was 1998 or 7 in there, they figured out how to run everything continuously in parallel, and that's when they came up with digital phosphor. That's where DPO comes from.
Digital phosphor.
Digital phosphor oscilloscope, with the idea that now you had the performance of like phosphor, like analog, and now your waveform capture rate was 400,000 times a second. So I'm now better than analog, and that's when things took off more. But with having the color, initially they could look at different channels and easier to see them on a multi-channel scope. Well, then they got the idea that now that you're doing all these 400,000 waveforms, you can show the frequency of when it happens by using color grading. So red happens all the time, blue happens much less often. So now you can get a an idea of frequency of events. And it's handy with like eye charts and things like that to see how often things are happening. So all that got built into this, and then that technology all got built on later as they built other scopes. And we have the design team.
Oh gosh.
That should be in there.
Why enough bandwidth? It was originally up to 500 megahertz, and then they pushed it to 6 with
And we produce
selecting.
these ICs?
Tech, I produced these, in '59.
Mm-hmm.
These hybrid circuits were built here in Building 13. These are relays that are purchased, from others.
Mm-hmm.
You put them, these are attenuators, front end stuff. You put them on ceramic so you don't have the moisture in the board affecting the signal. They hook and anyway.
So
It's
this
a
is your traditional.
Yeah, so
PCB.
so here's your front end.
Uh-huh.
Yeah, so it
So
mounts
it's
in
just
there.
like
Oh, okay. Mm-hmm.
Yeah, and then these are your digital. They used FISO in this, so these are your FISO ICs behind each channel, and then processing and CPU and memory. Another example of what you can do with a 465, you can have oscilloscope music. There was, I think, a couple of guys, I think they were in Europe, came up with this idea, get all the music and the graphics. We figured that they're probably not married and they're in their mom's basement.
That's funny.
Earlier we were talking about micro-channel plate.
Mm-hmm.
That got put into the 2467. That's why this front sticks out, because you had to have more depth. So the standard oscilloscope was this depth. They needed more depth with the CRT, so they just added this bump out the front. But this would go up to, this is 350 megahertz. I think the B version went to 400 megahertz. And again, it was one of the world's fastest
Is this
portable
digital,
systems.
right?
No, this is analog.
That's
This is-
analog.
Yeah,
Wow.
this is going, we went back
Oh, we
in
went
time.
back in time, okay.
Right.
Yeah.
We remember Roland Crop. We always said this is one of our best kept secrets. We never really, I don't think, marketed it.
Okay.
And this is a good example back here. We have some more dual beam oscilloscopes. Tech came up with the idea of having storage phosphor. So if I turn that on, this actually was built in 2 halves.
Oh wow.
And one of the applications was if you had, you can erase it, you would use 1/2, like for an instructor to put in words and have a wave shape. And then the student, who was a deaf person, would try to match it when they talked. And they could see on the screen how close they were coming to the stored. And that's why one of the applications for a while was split, or in 2 halves. Probably more significant, because this was a storage CRT, the early guys building computers, one in particular, Lucas, which I think preceded DEC, they wanted to have, instead of having like a teletype terminal or a paper terminal, they wanted to have a CRT for output of their computers. And so they would buy these oscilloscopes, mask off the amplifier and time-based stuff, and use this to capture text.
Oh wow.
Yeah. So that was the start of that. Well, that was when a guy by the name of Norm Winningstab was running the department. He said, well, the computer industry is buying something like that. Let's make them something that it's a little bigger and more purpose built. And so they came up with this Type 611 monitor that replaced the using a CRT. You had a bigger screen. It's still based on the storage phosphor.
Uh-huh.
Well, from there they said, well, we're making a monitor. Let's make a whole terminal. And then from making a whole terminal, they decided they could make a workstation.
This is a Lasky driven, right?
Yeah. Well, this actually uses bit slice technology. The 4051 was the first one. That was built on the basis of a 6800 8-bit Motorola microprocessor. Bit slice is a little faster, so when they did this 4052, they used bit slice technology. And we've done some things that instead of having GPIB, we have a memory module on the GPIB port, so we can plot more things. Something we have, instant art. Go ahead and type in your name. Oh, you can, that's fine. And so then it'll draw based on that is the input. We find this is quite popular with kids.
So that's your name in
Yeah, and with an algorithm to do vector graphics. So this is all done with drawing vectors. It's not a raster scan display. And in the beauty of it in the time was now you had storage on the screen. You didn't have to actually take up semiconductor memory, which was very expensive at the time, and not very integrated, and you didn't have very much of it. So it was quite a development. And we had a hard copy unit that actually used the CRT device, and you would right here, and it would put the image on the thermal paper. Wow. 1,000-point resolution. You can go bigger. This is like 3,000 points, and I don't remember what the diagram is, but you're getting quite big. It's monochrome, so you don't have the 3 pixels per 3 subpixels per pixel. We have a setup to be able to draw stuff. I'm not sure why that.
I didn't erase that.
Yeah. Yeah, like some of the stuff maybe needs to warm up. Head. with they had these they called them crayons that they would load for the colors. So different than like
Is that a
cartridges.
wax base?
Yeah.
Really? Huh.
And,
I would just heat it up and
yeah,
it'd start oozing out.
right.
Wow.
You would spit it out of the head onto a drum, and then the drum would roll onto paper, and so it would transfer that. Here's an example of one of the drawings, very saturated. But if you remember back in you know, late 80s, or 80s and 90s, if you wanted to do a presentation, you did it on plastic overlays that you would put on an overhead projector. And the laser printers were all not very good. They were not very saturated. The colors wouldn't look anything like what they did on the screen. And the inkjet was much, much better.
Is this part of inkjet here?
Yeah.
I have no idea. I always thought it was just fluid.
It's, well, it's
But ceramic with that. Is that gold plate? What is
yeah,
that?
it's gold plate. Actually came through. Originally, I guess they were painting those by hand, and then a guy came through here like 9 months ago. And he said, "Oh yeah, my grandfather invented the process for depositing gold in the funnel. Saved him a bunch of money. It was a lot thinner, more uniform, worked better." Anyway, so yeah, you can see this was all put together. These are what the molds look like. The funnel, and then this would go over it. You'd fill it up with the powder and fire it, and then take it out. We actually found, I don't know, hundreds of these underneath this building that have been stored away.
Of the molds?
Of the molds, yeah.
Oh, wow.
Got rid of them. They're still around. Oh, yeah. Tech was in the. They built the avionics displays for some time. That actually ended up getting sold to Planar. This side is more manuals. These are manuals to sell. And these are reference manuals for doing repair. And if somebody, they'll contact us and ask us for a manual. We can do a scan and send it out to them. These are scopes we're ready to
This should be no pound.
loan
They're
out.
sampled, they're flip-flops on a rising end.
Instrument library, so
These
we'll
are all
find you a
positive,
function
and then
generator.
one count 0, these are all negative. So then we want this one,
This is stuff, some for repair,
For
some
24.
just storage.
I'll count that. Yeah, okay, so we need
We
to
have a
split
lot
into
of
four.
stuff.
1024. Where is that?
The project going on to organize our parts.
That's disconnected anyway.
So
this will be,
that's part of what this is. And then you talk about the plugins. These are on the 7000 series and 7000 scope. 400,
we just need to take all
7K
these
series.
things up so we don't, so they're not
We've got a
exposed.
little bit of everything. Obviously, we don't have room to put it all out.
Okay.
Like the Smithsonian, the back
Yeah.
room.
Yeah,
Primes and
yeah.
show it out. And then we'll put this up, get a trace.
A lot of CRTs.
I have an actual ASIC that I need to figure out. It's a pretty simple one. It's a gate array, but it's not a field programmable one. It's a metal masked one.
Oh, you do?
It's in a tape machine I have, and it does a bunch of basic logic functions. And they put in your single IC. There's no description of what it does. I know what it does, but I don't know how it responds. So I'm gonna have to put the machine through its paces and probe all the outputs.
We don't have
Figure out, oh, they're doing this, they're doing this. Because once I do that, I can make an Arduino replace it if I need to.
rather not put it.
Because that IC ever craps out.